Welcome to Exorcism's Functional February, part of the 12 in 23 challenge to learn 12 languages in 2023. I'm your host, Bobbie Towers. This is episode 4, and this is going to be the last episode of Functional February. However, we're actually having so much fun that we decided to keep doing these all year long. So we'll keep doing this every Sunday, and we will get to do all sorts of fun stuff. So we've been learning functional programming by creating a functional programming learning platform, which is this Mario Paint music sequencer, which I've just added a code editor to, similar to the new code editor that I'm going to implement on Exorcism, where we have an inline evaluator, which let's see. So yeah, this is new. I didn't have this last time. I had the code editor, and I put the table with the key bindings here. First of all, let me put this link in the chat. And last time I said I was going to put the link in so that you could go to the site and follow along. And I realized that might have implied that this was some kind of multiplayer thing, which is not the case. But it just so happens that something really cool was released by Hyperfiddle. Let's see if I can find this. It's called Electric Closure, a reactive signals DSL for full stack web UI with compiler managed network sync. Now that sounds kind of complicated, but basically it makes it less complicated is what it does. It makes it so that the programmer does not have to think about the client-server dichotomy. There is no client-server dichotomy from the programmer's perspective. All I/O and effects are managed. See, you don't need a web platform. You need a web language. So this fully abstracts over the client-server state sync at the programming language layer. So you could do something like, say, like back in the day when we were using PHP, where you could just, it was a simpler time. But you're doing a query, and within the same function, we're making calls to both the server and the client. And it does this basically by turning your entire application into a signal graph. Performs deep graph analysis of your unified front-end, back-end programming to automatically determine the optimal network cut. So there is a demo. There's a thing here, somewhere here, is actually a starter app that you can just clone and go. Let's see if I can find that. But yeah, so this would be an interesting thing to do. Would be to try to make this a multiplayer. Now, to be honest, it's not really the use case that I have in mind for this app, but nonetheless, it would be really cool. So they're making all sorts of. Somebody did this one, electric Sudoku. First of all, I will put the link to this repo in the chat because this is just really cool and everybody's kind of talking about it in the Clojure world right now. And I'm really excited about it. So here we have an electric Sudoku, which the multiplayer Sudoku game using electric Clojure. And this is the kind of thing that you could do. Now, once again, I'm trying to think of how, now, yeah, I guess theoretically it would be really cool to do something so that, say, two people could work on a song together. Or, well, when I said that you could go to this link and follow along, that would actually be literally, you could literally, I could do stuff on the page here and it would show up in your client as well. And then you could like mess me up by erasing things. Which, this is the eraser. So I could actually do that on stream if people would be interested. It would be a fun project to try to implement this in electric Clojure. And now it wouldn't even necessarily be that hard because it's using a lot of the same technology. In other words, shadow CLJS. Right here we have the shadow configuration file, which actually only requires Node. Shadow ships as an NPM library. And so that would make a pretty cool stream, I think. But okay, last week, I also promised that we would get to Robot Simulator. So, you know, if you want my full like autism streams and my ADHD streams, you can go to my regular Twitch channel and subscribe there, where I will just freely go wherever my mind wants to go. But since this is still technically functional February, and well, one of the themes is that every week we focus on a new exercise. And one of them is Robot Simulator, which is allegedly a good exercise for functional programming. So let's figure out why that would be. Let's see, what is Robot Simulator? It's to write a robot simulator. A robot factory's test facility needs a program to verify robot movements, which the robots have three possible movements. You can turn right, turn left, or advance, like go forward. Robots are placed on a hypothetical infinite grid facing a particular direction, northeast, south, or west, at a set of XY coordinates, like 3, 8, with coordinates increasing to the north and east. Okay, so that's just telling us which way is north and east. The robot then receives a number of instructions, at which point the testing facility verifies the robot's new position and in which direction it is pointing. So it would be a string like RAALAL, which would be to turn right, advance twice, turn left, advance once, and then turn left again. Yeah, that's LAL. And say a robot starts at 7.3 facing north, then running this stream of instructions should leave it at 9.4. Okay, so it's just to here's our unit tests here. Okay, now this is interesting too. If we go over to the exorcism repo, there's actually an issue for this exercise, and I want to check it out because this is an issue from way back before I was even involved with exorcism. And when uh, when we released V3 and we kind of purged the teams so that uh, all of the exorcism teams were pruned to actually only the active contributors. And that was when I actually realized that it was just me. I hadn't actually accepted that, which means that I hadn't really taken responsibility over the track, the maintenance of the track. So when that happened is when I realized, oh wow, and there were like over 50 issues in here. And so what I did is I went through all of them and, well, I did like a triage to figure out which ones were maybe just a cool idea, but not, feasible or, uh, but there were a few of them that I decided to keep that I thought might be really worth looking at. And one of them is this is the first one here from 2016. 7 years ago. No, it was November, so like 6 years ago. And I did not know about exorcism then. This is an issue called eliminate implementation specific tests, and I believe the example that it gives is robot simulator. Inspired by a review of another issue or another PR, a new test was failing based on a poorly constructed state atom in the robot names exercise example. One of the beauties of Clojure and a fortiori testing in Clojure is being able to test pure functions with pure functions, rather than relying on underlying implementation details for mutable state. This issue calls for a review of all tests in the Clojure repo and their related examples to ensure that tests only check for functionality without relying on the behavior of particular stateful constructs to pass. I thought this was really interesting. And if we go to the, whatever this is this a PR? Yeah. Add test to robot name to make sure name in reset isn't hard coded. Actually, you know what I was thinking? Oh, here's Bork Dude. Wow, he was everywhere you look is Bork Dude. He's the creator of Babashka and like everything. They're calling it the Bork stack, which is the family. The it's a programming ecosystem, to be honest, that revolves around the small Clojure interpreter. And yeah, anyway, I think what I was actually thinking of, so that's also has to do with this same exercise, I think, but there was something recently. Yeah, here we go. This was only 1 year ago, since this was at the end of 2021. Um, tests in Robot Simulator are overly prescriptive. So it seems like a similar thing. And uh, when this issue came in, I was actually going through some personal issues and didn't have much time to look into it. So I wasn't actually sure what he was talking about, except I knew that it sounded good. I knew it was really smart, but I was not able to grasp it at the time. But the robot simulator exercise contains two tests that cause problems for students. And so if we have the robot simulator turn right, that is pointing west, then we should get north. So that's just testing the functionality. It's a test that a robot can turn right. And then likewise, if it turns left when it is north, then it should be west. And he says, okay, now this is really interesting because so far the other issue was actually only about it being a problem of not testing pure functions, which would be an optimal way to do it in Clojure. But here, Carl says a completely valid approach would be for turn left and turn right to accept a robot as input and produce a robot as output. That does sound really good. However, the tests preclude this approach to solving the exercise. I would advocate for removing these tests. Okay, so then I asked, I like the way you're thinking. Would removing just those two def tests do the trick? And this was at the beginning of last year. And so this person is probably busy like I was. So let's go to the actual exercise and see if we can go through it and figure out what he was talking about. Here I've got in my notes the robot simulator, and I was planning on using the Clojure representer, which would be a way of generating from the last 500 submissions, which were the most commonly used approaches. But when I did that for one of the exercises before, and then what I did is compared it to the community solutions that I have these sorted by the most stars, and I actually liked the community usually converges on some really good solutions. So here's one using cycle and drop while. Now cycle, okay, now that's interesting. I already realized I like this solution because it uses reduce. Yes, perfect. So let's just grab this. And now one of our goals in the next 3 months is to implement the inline evaluation in the exorcism track, which would make it so that I would actually feel really good about working this out in this editor here. Let's just make sure it works. Okay. So what I'm going to do instead is put this into my editor here. And we're going to demonstrate some of what what I mean by inline evaluation. Let's see I'm thinking if I zoom in, yeah, that's great. It's still, yeah, that's cool. It makes the HTML elements bigger, which is great so that you can see the code really well. But this music UI is implemented in SVG, so it automatically automatically scales it to the width of the browser. So I like this. So in our tests, so we looked at two issues, GitHub issues that dealt with this exercise. And so the first one was about the tests relying on a specific implementation, which is here we're defining a robot named Robbie. Now, I always hated it when teachers would call me Robbie. Like my name used to be Robert. I never used Robert, like ever. I always hated that name, but Rob or Robbie were even worse. So a better way of doing the tests would be, instead of doing this, to just test pure functions with pure functions, which, as they said, was a great strength of Clojure. So we have a robot named Robbie. I'll just put this here. So what I need to do is evaluate, yeah, so I have these, this is the table for the key bindings. So I can show how the, what features we have, because these are basically, these editor commands fall into two categories. There are structural editing commands for navigation, or to take advantage of Clojure being a Lisp, which means we can do things like slurp and barf. Which, those are pretty much the only ones that I use. I'm not a huge fan of par edit, or I really should. I really should use it more often. And since I have this table here, maybe I will. So these are the ones that the next journal Clojure mode for CodeMirror 6 has implemented. So we can barf backwards or forwards. The one that I use a lot is slurp forward. So that's, well, on my platform, it's control right. But another thing that's cool about this table is that it's aware of your platform. So since I'm actually using Windows, it says control, but if you're using a Mac, it will say command. That'll be your modifier key. So slurp forward is your modifier key and right. And so I'll show how that works. It'd be like, let's say we're going to map something, like we learned map. Actually, all of these streams, we pretty much have done something with map. So if we were mapping ink on a vector of 1, 2, 3, 4, and when I'm not actually writing code, I'm trying actually drawing a blank on how to. I'll just do it. Okay, let's say it doesn't have to make sense. Let's say I want to make this, and I want to slurp the ink into the 1, 2, 3, 4. So I would do that, or like that, and then barf is the opposite. and that's really helpful for when you have a language that lends itself to structural editing, structural navigation. The navigation thing is really useful too. So navigate. Okay, so that's Alt. Which for me it's Alt. Navigate right. So is that what will go? It'll move the cursor. Is Alt right? Yeah, that I find that incredibly useful because that's like all the time. I'm doing something at the beginning of the form, and then I have to put my hand on the mouse because I want to go to the end of that form to start writing more code or whatever. So instead of having to do that, let's see what happens if I do it from inside the form. Oh, and then it jumps. Oh, that's cool. So yeah, that's really cool. Now, let's say, so that's structural editing, structural navigation. And then there's also inline eval. So here's how that works. Say I want to evaluate this form without having to, now see, this is the real point that I want us to understand is the value of this and why we wouldn't just why we wouldn't what we would really gain by having an output window on the exorcism editor when you might say we could just run the tests and get the output. That should actually be all we need. So, let's say at the end of here, we'll print something. We actually get an error. So that's something we could also improve. What if I just have the string? Let's say I have no code. So so that's, I don't want it to pass. I want it to, yeah, that's interesting. We get no, oh, because let me revert to the exercise start so that we just have a clean slate. So that way we have the robot function is just defined as a thunk. I think that's what that's called, as a thunk. It's just a function that's like it's a no-op. That's probably the actual term. If I put a string at the bottom of here and say run tests, and yeah, this is giving us an arity exception because our robot is supposed to have wrong number of args passed to. Yeah, it's trying to run the tests. Anyway, the whole point I'm trying to make is that this editor isn't very good at the moment. It's very cumbersome just trying to show basic input-output operations, which we can do in here. So I have my cursor. You want to just evaluate one form, you put the cursor at the end of the form, and now it is it's eval top level. So every top level form is like a def or a defen, something that and so eval top level is Alt Shift Enter. But Actually, the one that's the most useful, well, eval at cursor. Yeah, that's the one that I use most of the time. Eval cell. Okay. Control enter evaluates the entire cell. Now, if I do that, it might actually crash the this might crash the page because I haven't finished the error handling yet. So I'm just going to copy this in case it does. So Alt enter. Oh, no. Oh, no, cool. So there we see the output down here. Now, if you want to evaluate at cursor, that was Alt enter. That's what I just did. Okay, control. Okay, let me try control enter and see if it. Oh, now that crashed the page. I don't know why. So we have our robot named Robbie. Eval at cursor, Alt enter. Okay, so I'll evaluate Robbie and could not resolve symbol robot. So yeah, we need to define these things. So that switches to our namespace. That defines our directions. It's just a private variable, which I'm going to actually, I don't normally use private variables, and it just looks noisy to me. So I'm deleting it. And same with this defin with a hyphen makes a private function. And what does it? I think Guido, the creator of Python, said we're all consenting adults here. We don't need to make things private. I don't even know what he was talking about, if that had anything to do with this. But anyway, so here are our directions. And we have a function that is a turner, which takes directions. And these are two variables, turn left and turn right, that use the turner. So what is directions? The directions that are passed in. Let's start from the test cases and work backward. Here's one that's fairly normal, I think. What I'll do is evaluate these forms. Now, it just occurred to me that this might not actually be a stateful environment. Let's say let's say I make, let's say I define something. And so that's defined. And so then can I call it? Oh, yeah. Okay, cool. Nice. So here we have our directions. East, south, west. Wait, that's weird. Huh. Why is it outputting that? Let's see. I'll use the type function to find out what it says it is. See, type. No, it doesn't tell me. So if you run into the problem where I'm actually not a fan of this at all, see, it's not letting me delete this this closed parent here, which I actually find like kind of a hostile feature. So I might turn that off. What I do to get around it is you're allowed to cut just to Control X and cut the parentheses. So, but you know, actually, I didn't want to do that. what I wanted to do is just see if we can take the first. What's the first of directions? North. Okay, so yeah, it's still correct. I think it has something to do with it must be escaping certain characters in the output. I'll have to take a look at that some other time. I don't know if I evaluated these yet, but it doesn't matter. I'll just wonder if there's a command that formats it. Indent. I wonder if indent formats it. So that's just a tab key. Yeah, let's see. I did it just do it? Let's see. Huh. I don't know if it put that there on purpose or not. So that's our advanced function, which takes a map which includes the keys, coordinates, and bearing, which I think we're representing a robot as a map. Yeah, so that advanced takes a robot and where did we define this is calling bearing, but what is bearing? Okay, now that's interesting. This I'm What is the bearing function? Where did that come from? That's not a real closure function, is it? Go to closure docs. No, I didn't think it was. Let's go back to the community solutions. Bearing. It works because it's a key, or it's a keyword. Yeah, okay. Yeah, I understand now. It's a key, which in Closure you can call a keyword on a map. So say we have a keyword called hi, and we have a map that has a key hi, and which is mapped to a string hi. So we call this, and it says hi. So it's a keyword is a function that looks itself up in the map that it is passed. So that's cool. It was an opportunity to teach that, and so that's what's going on there. That had me confused a little bit, but that's cool. So it retrieves the bearing by calling it as a function on this map of now. That's a robot. Is this a robot? All right, so here is our, that's private. This just maps each character to a function that are the actions. So A is for advance, and then we have left and right. So left takes it takes a robot, right? And in the bearing key, it replaces the value with the current bearing passed to turn left. So it turns the robot left, and that's L, and right is right, obviously. So now we can define a robot. And we can see here, so robot takes a set of coordinates and a bearing, like north, south, east, west, and it creates a map of those with those keys. And the simulate function takes, it looks like that. It's it's a call to reduce, which is one of our favorites. You know it is. That simulate takes a set of steps. I imagine it's like, oh, I guess it's a string. Yeah, it takes a string with the steps and a robot. So now we can, wait a minute, why is it, could not resolve symbol robot. Why not? Did I not? I guess I didn't. Let's see. Oh, because it's calling from the test case, we're calling it's in the robot simulator namespace, but right now we're just in our user namespace. So there we go. So that's Robbie, and let's call, actually it's not a function, it's just a definition. And so this is what we have. So the coordinates are passed in as a map with keys for X and Y. So that's cool. And if we simulate this RLAALAL on Robbie, oh yeah, we need to just call plain old regular simulate. And we end up at coordinates 0, 2, facing west. So we'll break down what's happening here. And so we have this, what I'll do, I think, is we'll go through this solution first. So I'll break this down, and then we will try to rewrite it the way that Carl suggests, by instead making a robot accept for turn left and turn right, to accept a robot as input and produce a robot as output. So what I'll do is take this test case here. And so if we are facing west and we turn right, then it should output north. And let's see how that worked. Our turner is really cool because it uses cycle, which we looked at last time for the, we used cycle to create a scale, which, let me open another instance of the page so that I can show that. Because that's what, that's another thing that I added to this editor. I added, this is what we did last stream. And so I made it so that that's how this page ships now. It comes preloaded with these functions for making a scale with reductions and cycle. And I added the blues scale because it's a good scale. And here I have a function scale node. Which what this does is it takes a value or a note, scale note. So let's say 5. Yeah, so let's say we're outputting something and it's a 5. What it does is it gives us 70, which is the note of the that would be using the blues scale. In other words, it's scaling it to the scale. And so then we could take, that's what this function is doing here. It's taking our notes, which just for a simple example is just the integers 1 through 10, or that's actually 0 through 9. I can demonstrate that. We go, yeah. See, isn't that cool? I could put the cursor just there, and so that's 10, and range 10. So it evaluates it depending on exactly where the cursor is. So then we have a certain number of beats, which number of beats is the number of notes. And we create a note for each one of those. And then the notes will be on each beat. The pitch of the note will be determined by the value passed in. And if we just say scale note of nth notes beat, so that beat of the set of notes, so then this would give us these notes. And it will be in the blues scale. So now if I evaluate it using this closure symbol, evaluates and puts it on the screen. So then I could play. Yeah, so that we have a blues scale starting at 60. We used which is being passed to reductions so that it adds the value of that note to, see, otherwise, if we started it at 0, that would be like subsonic notes. Or it would just be, yeah, too low. We could change it to the heart by changing the instrument. I think that's 15. And that way we can listen to the output and it will be somewhat musical. Then again, for a robot, I don't think of the blues. For a robot, we use lots of octaves. It would be, we would want like an octave sound for that. You know, robots, a robot can't have the blues. It's it's not capable of emotions. So here we have our Turner function uses the cycle function again. So that's cool. And it cycles the directions. So what does cycle do again? It creates an infinite sequence from a sequence. So, okay, the directions, these are our directions. So if we, let's see what happens if I just cycle the directions. So here we're evaluating an infinite sequence. So I'm gonna, just as a good habit here, to just select all and copy. You know, that way, in case the page crashes. Oh, you know it. Oh, yeah, it frees. It's free. It froze it. That's funny. It's trying to evaluate the infinite sequence. So I'm gonna have to actually exit that page. Good thing I copied the text. Oh, but what I have to do is I have to evaluate the cell again, and I can just evaluate the whole cell theoretically with what? Eval cell. Oh, is control enter. Let's see if that blows up. No, cool. So now let's see if we can evaluate Robbie. Oh, why wouldn't that work? Eval cell, control enter. So if it didn't do that, I wonder what it did. Okay, so I won't evaluate this then. If you want to, we can always use take to see just the first 5. And here's a good opportunity to use slurp. Now, so I go control right, and it slurps. And also now I can do alt right to alt right, oh boy, to get to the end of the form. Cool. So those are 5 of our directions. And so that's what we're passing. That's what we're starting with here. Now this is, I'm going to modify this to not use this threading macro. Because what this is actually doing, I will, let's see, I'll cut that, and it puts it, it's the thread last macro, which puts it as the last item of that list. And now I'll get rid of this and get rid of this. I define the Turner function. Turn left and turn right. So what the Turner function does, what we want to do is refactor it so that it takes a robot. That's actually, but the problem is that these tests for the exercise test suite prevent you from doing that. Because, let me get back to it. So that's what he means by overly prescriptive. So this would probably be a case where this probably was generated from the problem specifications repo. And this might be a case where we want to actually not do that. Because it's prescribing, which it's prescribing that the turn right function takes a direction. When if we want to just turn Robbie right, oh, I broke it. Oh, now I think, yeah, now I lost what we were working on. Oh, well, let's see. I don't think we actually need to have a namespace. So those are our directions. So what do we need to define Robbie? You know what? I'll just go through and all right, let's see if this will format. Oh, nice. The format does work. You just press tab. Oops. All right, now we need Robbie. Where'd you go? Yeah, see, it's okay. Now we have Robbie again. Wait a minute. I forgot what I was doing when what made it break last time. So let's say we want to take Robbie and turn him left. Our turn left function should be able to take a robot rather than the string. And it seems like that my question that I asked on the PR was whether removing just those two def tests would do the trick. And so I've only actually got a few minutes left, but hopefully we can try to at least see if that works. First, we'll show how the Turner function works. If this just takes the set of directions, yeah, how does this work? This is interesting. The simpler one of these is turn right, because it just calls directions, calls Turner with directions. Let's see where this is used. What calls turn left and turn right? Actually, that was in the test cases, right? Yeah, so we just want to just get rid of these tests, I think. Because we don't care how you do that. This is guiding the student to solve it a certain way, which is not necessarily the best way. Let's see where in the solution that uses turn left and turn right. And that would be like here. So if one of the characters in the string is an R, then it will do this to our robot. Oh yeah, we have bracket matching, and I even like it wasn't very visible. Maybe because I made it pink. Yeah, when they made it was supposed to be white, but I made it pink, and so I made it like extra bold and black, so that I can see where the other bracket is. So now I can just isolate this. And actions takes a robot. Okay, cool. So we could replace this with Robbie. And if I evaluate this form, oh, and we is that right? Did that yeah, okay. So that's the output of that. Is there anything else that calls turn left and turn right? Yeah, cool. So nothing else does. So if we just modify these, and then we won't have to worry about anything else. So let's take just this function, turn right, and the bearing of Robbie is east. And so turn right just takes that and outputs south. I'll actually bring this, we're not worrying about the advanced function right now, just the turner. And we're going to make another function called turner, which instead of taking a set of directions, where does, yeah, it takes a robot. I'm going to do what I did last time, where I'm going to rearrange this. Yeah, so if I partial, we haven't introduced partial actually, and you know what, I'm out of time, so we will continue with this exercise next time. What I will do is I'll copy this into my notes here, so that I'll be able to continue right here next time. All right. Well, thanks for joining us. And that's it for Functional February. But it's not it for us. Mark your calendar for next Sunday, same time. And we'll do some more closure and some more music. Have a good day, everyone.